Okay, let's go ahead and start our notes on 10.6. Our notes on 10.6 are our reasoning in algebra and geometry. How do I complete a two-column proof is what our essential question is. By far, these two-column proofs are what your parents remember as the hardest part of geometry. They literally are something that is more difficult for the general population. So I'm hoping that I can explain to you how easy this is. You just have to know a few things first. So let's start talking about this word, proofs. Proofs. Let me scoot this up. Merry Christmas. Thank you. Thank you. You're welcome. Proofs are usually made up of two columns. The left side is the math. The right side is the mathematical reason. Let me make sure this looks like an F. Proofs. Proofs are usually made up of two columns. The left side is the math. The right side is the mathematical reason. What you are going to do today is you're going to do the basics of a two-column proof. What you should be able to do by the time you're done is recognize what a two-column proof looks like, and you should be able to fill in parts of a two-column proof. In Math 2, you will have to write your own two-column proof. In Math 1, you will not create your own two-column proof. You will look at somebody else's two-column proof and fill in the blanks. So you should have a general idea of what a two-column proof is. Okay? Let me give you an example. Number 2. 2x minus 12 in parentheses equals 40. Let me scoot this up a little bit. And then it says 2x minus 24 equals 40. Then it says 2x equals 64. Then it says x equals 32. Then it says this. It says given A blank, B blank, C blank. This is an example of a two-column proof. This is column 1. This is column 2. In a two-column proof, the left side is the math. This is the math. There was somebody else's problem and somebody else's work. The right side is the mathematical reason, you can do what you did on the left side. Okay? Before we even fill this thing out, the first thing I want to point out to you is the first reason should always be given. The first reason should always be given. What this means is, when you look at a problem, when I just look at this, how do I know that 2 times the parentheses of x minus 12 equals 40? I know that because it was given to me. That's what I'm starting with. That's what I was given. I was given that this is the problem. The problem is 2 times something, x minus 12, is equal to 40. That is given. Given means that's what you're starting with. That's what you're given to begin with. Okay? The first reason should always be given. I need you to know that. Okay? That's why that reason is that. Now, what happens with a 2-column proof is you have to start filling in reasons why the other person, whoever wrote this, you have to fill in reasons why they did what they did. Now, what you need to do is you kind of need to look at this and look at from here, from this step to this step. They did something. They now have, instead of parentheses, they have 2x. And instead of minus 12, they now have negative 24. Do you know what that person did? Let's start with Logan.
They distributed.
They distributed. That is absolutely correct. There is a property called something that is a mathematical reason why you can do that. And it's called the distributive property. Distributive property. And I'm going to write of equality. You do not have to put it in there if you do not want to. Of equality. Let me scoot that over just a little bit so you can see because it's being cut off. There we go. What did they do? They distributed the 2 to the x and to the negative 12. You guys can put that right in the blank. I'm putting it off to the side because I'm going to share this with my next class, and I'm going to cover that part up so they can see that there's blank spots. Okay, from this step, from the step A to step B, they did something else. The 2x minus 24 equals 40. This minus 24 went away. The minus 24 went away, and now it becomes 64. What did they do? Ray.
Subtraction property of inequality.
That's not correct. It may seem like that, but that's not what they did.
Did they add it?
What did they do to get rid of the negative 24? They added 24. If you add 24 to the left side and you add 24 to the right side, you're not doing the subtraction, you're doing the addition property of equality. So I'm going to write that down. Addition property of equality. Whatever it is that you're doing to both sides, if you've added the 24 to both sides, you're doing the addition property of equality. Just because there's a subtraction doesn't mean you're going to write subtraction property. Just keep that in mind. Now we go to the third and final step. We have 2x equals 64. Something happened between to go from 2x equals 64 to x equals 32. They did something. I've already called on both of you two. I need somebody different besides you two. Alex, what do they do?
To get x by itself, they divided it by 2, both sides.
Perfect. They divided by 2. Guess what property that is called? Use your common sense. What
Division
property is called? Exactly. Division property of equality. That is, those three reasons fill in the two-column proof. You basically have to look at somebody else's work who already did the work, and you have to look at the reason. Now that's kind of like beginning level, by the way. Some problems, you're going to have a reason, and you're going to have to actually fill in the left side as well. And by the time you get to your chapter test, sometimes there's going to be a blank on the left side, and then there's going to be some reasons on the right side, and you're going to have to fill in blanks on both sides. Okay? That's as hard as it gets. Okay? So now, that's an example. That's what a two-column proof looks like. Now, what that brings up to me is, man, what properties, what reasons are there in math? We have a whole list. If you look at your check sheet, have you seen it? Let me pull out a check sheet for those of you who haven't seen it. Here's my check sheet. I'm going to flip it over. All of, let me zoom out a little bit. Here are the reasons for proofs. There's the addition property of equality. Hang on. There's the subtraction property of equality. There's the multiplication property of equality. There's the division property of equality. There's the distributive property of equality. It's also called multiplication over addition or over subtraction. It's still distributive property, substitution, reflexive, symmetric, transitive, and so on. Okay? So, here's the whole list. You have all these things, and these are what you're going to use when it comes to filling in proofs. Some of you have never seen a few of these reasons, and so I'm going to talk about some of those reasons specifically. Additional reasons for proofs, things that are not on this list that you might use. You also might use definitions, postulates, previously proved theorems like the Pythagorean theorem, and algebraic properties as well. Now there was a question. Logan, what's your question?
We have that list on the test.
Some things maybe I forget. I'll let you know when we get closer to the test, whether we have them or we don't. Okay? Ray?
Are postulates for next year or?
Pretty much. You will use them a lot more next year. We're kind of introducing postulates for this year. Okay? So here's what I want to say about these reasons. I think that addition property, when you add something to both sides, I think that's common sense. I think you've been using the addition property for so long that a lot of you already know it. I think subtraction, you've subtracted things from both sides of equal sign. You know that one. You know multiplication. When you divide both sides by something. I think these four things, and maybe even the distributive property, all of you are almost experts. Okay? Those are the common sense. But then we have some other ones that you are not very familiar with, like substitution, reflexive, symmetric, transitive, and I want to talk about those ones. Let's write those ones down real quick. Okay? Okay? You know algebraic reasons. Wow, that's way zoomed out. You guys know the adding, comma, subtracting, comma, multiplying, comma, dividing properties of equality. I believe those are common sense. I think you've seen the distributive property of equality. But the ones that I really want to highlight to you is the substitution property of equality. I want to write down the reflexive property of equality, symmetric property of equality, and the transitive property of equality. James? Can you wait till after notes? Thank you. So these four that are new reasons why you do something is I want you to have some examples of them, okay? So the first example that I want you to write down is the substitution. If you ever plug in a number for a letter, that's the substitution property. So here's what I have written down from last year. If you ever know that A equals 7 and 2A plus B somehow becomes 2 times 7 plus B, if you know that A equals 7 and you have 2A plus B and it somehow then becomes 2 times 7 plus B, what did we do with the A? We substituted in a number for a letter. It doesn't always have to be a number for a letter. Sometimes it could be that A is the same as B and we can plug in a B there, and that would also be substitution. So whenever you substitute in one variable for another, or a number for a variable, that's the substitution property. Reflexive. The way I think of the reflexive property is I think of a man or a woman flexing their muscles. I can just imagine Cassie going boom with her right arm. She shows how big that bump is, maybe. And then, yes, I did. And then she goes and flexes her other arm, her left arm. And since she does her training equally, her left arm and her right arm are the same. So the reflexive property is whenever you see the same thing on both sides. Whenever you see BC is equal to BC, that's the reflexive property. If you ever see something equal to itself, that's reflexive. Symmetric, on the other hand, is a little bit different. If you ever have that this left side is equal to the right side, if AB, if that segment is 6, the symmetric property will be the opposite. It'll be symmetrical. It'll be in the opposite order. If AB is equal to 6, then 6 is equal to AB. Anytime you switch the order, that's the symmetric property. Transitive, on the other hand, if you know two values are the same, if A equals B and B equals C, then A equals C. That's the transitive property. These are the additional reasons you might need for a proof. The other things that I wrote down here, I have a few others. I call these the other reasons. What I wrote down last year, segment addition postulate. I also use this one, combining like terms. Two other reasons for you to use. So what is the segment addition postulate? We wrote it down a long time ago. It looks something like this. This is what the picture looks like. It's where we said AB plus BC equals AC. If you ever have one segment piece plus the second segment piece, this piece plus this piece equals the whole piece, that is the segment addition postulate. If you're adding two segments together, it's going to equal the whole segment as long as they're collinear, by the way. Another reason, the last reason, if you ever simplify, you're combining like terms. For example, if you have 5a plus 6 minus 7 equals 11. Let's say you had that, and your very next step was that they put the 6 and the negative 7 together. And they have 5a minus 1 equals 11. What's the reason you can put the 6 and the negative 7 together? We call that combining like terms. Combining like terms. Some people call it simplifying. If you want to write simplifying for combining like terms, I would accept it. But the mathematical reason is combining like terms is technically the distributive property for anybody who's super advanced. That's the reason why. So that takes us to these two column proofs. I want you to look at number 8. And we'll do number 8 together. And then we'll be done with our notes. Almost done. Focus, focus. So for number 8, you have a 2-column proof, and it has a lot of stuff written on it. Segment AB is the bisector of angle CAD. Number 2 says angle CAB is congruent to angle BAD. Number 3 says the measure of angle CAB is congruent to the measure of angle BAD. Number 4 says 7x plus 2 is equal to 5 parentheses x plus 4 plus 4. Number 5 says 7x plus 2. This is why we're doing it. By the way, if you don't feel like writing this down and you just want to pull out your packet, you're welcome to do so. But I need to write it down so I have it in my notes. Number 6 says blank. Number 7 says blank. Your reason on number 1 is given. Number 2, blank with a question mark. Number 3, congruent angles have equal measures. Oh man, there we go. Number 4, blank. Number 5, blank. Number 6, blank. And number 7, blank. Question mark, question mark, question mark. Woo! Okay. One other thing that I forgot to write down is right at the top, since I have room. It has given. AB is the bisector of angle CAD. Prove x equals 9. Question, Ray?
No, I have the answer.
No, I don't want the answer. Okay. So here's what I need you to know about a 2-column proof. Earlier I told you that there's mathematical reasons. This one is, Ray, that's distracting me. Thank you. Okay. This proof is a geometry proof. This is used a whole lot more in Math 2. But it's a good for us to wet our feet with it so that you guys get ready for this, because a lot of you are going to be having issues with this next year. In this proof, not everything is black and white. Not everything you're going to feel like that you understand what's going on. But let me just say this. You're given this in the problem. It tells you what's given up here. It gives you a picture. And you need to prove x equals 9. Okay? You're always trying to prove the thing that it says up here. That's the last, usually, that's what goes here in this blank spot for number 7. That's what I'm trying to prove. I'm trying to prove that x equals 9 by filling this whole thing out. Okay. AB, segment AB, is the bisector of angle CAD. Guess what? That was given to us. Right? So then I go to the next step. Angle CAB is congruent to angle BAD. How do I know that this angle is the same as that angle? Ray, you can do it first.
Transitive property?
It is not the transitive property. Logan, what were you going to say?
Symmetric.
It is not the symmetric property. Ray?
Reflective?
No.
Wait, what?
This one is, we have to look at the picture, okay? CAB, this angle here that I'm pointing at, let me highlight it with, no, I'm not even going to highlight it. Here's CAB. Maybe I'll do a color. Let's do a color. CAB. This angle, that's this angle, is congruent to this angle. They are congruent to each other. How come? Why do we know that? There.
Bisector splits it into 2.
Ooh, you're getting so much closer. He said because the bisector splits it into 2. Ray.
Segment bisection property?
There.
Angle bisection property of equality.
No. Okay. So let's go back and let me highlight what I talked about earlier. These are your properties. You're not using any of those properties. Sometimes you have to use additional reasons for proofs. We might need to use the definition of a word. There's a key word in here that Logan was touching upon in what was given. AB is the bisector of CAD. Do you know what that word bisector means?
Splits the angle into 2 equal different angles.
It splits it into 2 equal or 2 congruent things. So I know that this yellow angle and this orange angle are the same angle because of this word. What am I using? I'm using a definition. So for number 2, I'm going to put my answer down here. You can feel free to write it in somewhere where you want. For number 2, I'm using the definition of...
Bisector.
What kind of bisector is it? Is this a segment bisector or is this an angle bisector? Angle bisector. That's your first reason. That's how you know it, because you're using the definition of one of those words. Now, the measure of angle CAB is congruent to the measure of angle BAD. How do we know that? Because congruent angles have equal measures. They gave us that one. That's a little bit harder. I wouldn't expect you guys to really know that one, but we can follow along somebody else's work. They gave us the reason, thank goodness. Okay, let's move on. How do we know that 7x plus 2, how do I know that this is equal to the 5x plus 4? What did we do now? We've already proven that the yellow angle is the same as the orange angle. What are we doing now that we're putting in this value in for angle CAB?
Substitution.
There we go. Connor says it. It is the substitution property. How do we know it's the substitution property? Because we're substituting in 7x plus 2 in for angle CAB, or the measure of angle CAB. So for number 4, the reason is the substitution property of equality. Now, let's look at what we have for number 5. Number 5 has a 7x plus 2, and then they have this 5x plus 20. They did something from the 4 to the 5. What did they do? Good. So what property are we using? Good. Number 5, distributive property of equality. Wonderful. I'm going to scoot it up a little bit. If you wonder, oh wait, they didn't fill anything out here, remember what they're trying to prove. They're trying to prove that x is equal to 9. That's what we're trying to prove. So if you're trying to figure out what are they going to do next, my guess is they're going to try to solve for x, and it should be 9. What do you think they're going to do next? Wait, tell me the math that they're going to do next. What would you do to get x by itself? Go ahead, Ray.
So I would do subtraction property of equality.
You're giving me a reason. I want the math.
I'd minus 5x from both sides.
So there we go. Minus 5x from both sides. Would you subtract 5x from both sides to get x on the same side of the equal sign? Okay, so that means on step 6, if we subtract 5x and subtract 5x, what is going to be over on this left side?
2x plus 2.
And if I subtract 5x from the right side, what's going to be left? Okay, so that's what step 6 should look like. Would you agree?
Couldn't you minus the 2 in the same step?
But then we'd have to have a different reason, right?
That's still the subtraction property.
Oh, look at, well, here's what Connor says. Connor says, could we also subtract the 2 over from the 20?
Yeah.
If you do, what does that become? And what property was that?
Subtraction.
Is that the same property as we used for the 5x?
Don't you have to have two though?
Yeah, what do you have to have 2 reasons?
Wait. Is it the same reason for both steps?
Yeah.
Now that's going to help us. You know why? Because now we have, this is step 6. What's the last step we're going to do?
Division.
Will that give us our final answer, the thing we're trying to prove? See, because I only had 2 blanks and I had 3 things to do. I had to subtract the 9 and I had to subtract the 5x, or I had to subtract the 2 and the 5x. That gave me the right amount of blanks left. Number 7. After we divide by 2, it becomes what? Is that what you're trying to prove?
Yes.
You're always, your last mathematical reason, or your mathematical reason should be the thing you're trying to prove. And what was our reason for that? What did we do to go from 2x equals 18 to? Division property of equality. Let's end your notes right there.